Okay, so for today's lesson, we're going to multiply radicals, and we're going to use the product property kind of backwards, where normally when we had one big radical, we could separate them into two separate radicals using multiplication, but now we're going to kind of go the other way. And if we've got two radicals being multiplied together, we can multiply both those numbers and put them under one radical. So the idea is, remember though, you can only multiply numbers that are both outside the radical, or you can only multiply numbers together that are both under a radical. You might need to use a distributive property, and as always, make sure that you simplify your answer. So what's happening here for this first one is I'm going to use that product property. I'm going to say, well, radical 3 times radical 15 is the larger radical of 45. And under 45, 9 is a perfect square factor. 5 is the non-perfect square factor. The square root of 9 is just 3. Root 5 is irrational. And that's your final answer simplified. Number 2, I've got negative 5 radical 3 times 4 radical 6. Remember, you can only multiply both numbers that are outside the radical and those that are both inside. So the outside numbers give you negative 20. The underneath radical numbers give you 18. And in 18, there is a perfect square factor. So negative 20 radical 18 becomes negative 20 radical 9 radical 2. Well, 9 is a perfect square. Its square root is 3. Negative 20 times 3 is negative 60 radical 2. On number 3, you're going to have to use a distributive property. And when you do that, you're saying 3 radical 2 times 1 radical 6. That's just 3 radical 12 plus 3 radical 2 times 1 radical 2. And that becomes 3 radical 4. Well, it turns out that radical 12 is not a perfect square, but can be broken down into 3 times radical 4 times radical 3. If we just stick with this for right now, the square root of 4 is just 2, which means just at 3 radical 12 turns into 6 radical 3. The other part, though, is plus 3 times the square root of 4. Well, the square root of 4 is just 2. So this becomes plus 3 times 2, or 6, which means your final answer becomes 6 radical 3's plus 6. They're not like terms. You can't go any further. Another distributive property. 2 root 5 times 7 root 3 is 14 root 15. 2 root 5 times negative 1 root 10 is negative 2 root 50. Well, square root 15 doesn't have any perfect square factors, so 14 radical 15 comes down as is. Radical 50 does have a perfect square factor. Radical 50 can be broken up into root 25 times root 2. The square root of 25 is a perfect square, and it's just 5. Final answer here becomes 14 rad 15 minus 10. 2 times 5, radical 2. Don't have like radicals. Final answer is there. The last one you're going to be doing is a binomial times a binomial. So distributive property or FOIL. Let's see what happens here. 2 rad 3 times 3 rad 3 is 6 rad 9. 2 rad 3 times negative 5 rad 6 is negative 10 rad 18. 4 rad 6 times 3 rad 3 is plus 12 rad 18. 4 rad 6 times negative 5 rad 6 is negative 20 rad 36. Well, as it turns out, rad 9 is a perfect square. Square root is 3. This turns into 18. These guys right here are like radicals. You can combine those guys together. And if you have negative 10 root 18 plus 2 root 18, you're going to get just negative 10 root 18 plus 12 root 18 is going to be positive 2 root 18. This next part, the square root of 36 is just 6. Negative 20 times 6 is negative 120. We still have some square roots to simplify. So we basically have, and I'm going to combine these guys together right now too. This 18 minus this 120, okay, that's going to end up turning into negative 102. So I'm going to put my negative 102, and then I'm going to simplify the square root of 18 by making it root 2 and root 9. Square root of 9 is just 3. And this becomes negative 102 plus 6 rad 2. Okay, and that is it. So you should be good for the rest of the homework.